Hello viewers, my name is Mr.Adebanjo and I want to wish you compliment of the season from here, from wherever you are watching this video in the part of the world. I want to say a Merry Christmas and Happy New Year in advance to all our viewers and all our followers. And I want to welcome you to this series on Venn Diagram. I want to welcome you to this video on Venn Diagram. And this is the second phase of set theory. In this first phase, we have talked about set theory. We have talked about all the terms that is being used in set theory, such as universal set, empty set, complement of set, intersection of sets, union of sets, cardinality of sets, and how we could use them to solve problems. We have talked about those that in the previous video we have made. So if truly you want to really understand this video on Venn diagram, please you need to refer to how we to that video we have made in the past on sets, so that we can understand this Venn diagram easily, because you need to understand those terms that we have in sets, such as those one I've just mentioned now. You need to understand them so that we can you understand Venn diagram as well, because we are still going to be using those terms under Venn diagram. So before we continue, please, if you have not subscribed to this channel, please hit the subscribe button right now in the channel, so that you will be notified whenever we post videos, and you can also click on the bell button so that you'll be notified, and so that you can help us improve the good work we are doing on the channel. So what are we expecting in this video? I told you earlier we're going to be talking about Venn diagrams, and we'll be talking about what Venn diagram is all about, then the components of Venn diagram, that is what made or make up or a Venn diagram. Then we'll be talking about Venn diagrams of two subsets. Then we are going to be solving we are going to be solving some question on Venn diagram of two subsets. I want to tell you we are going to be solving a lot of questions. Lot of questions are going to be solved. Question on WAEC, past questions, question on from different materials, different textbooks. We have combined them together, and we are going to be solving them together step by step, and I believe you are going to understand them if you follow up. Then also in this video also we are going to be talking about Venn diagram of three subsets, and we are going to be using it to solve question also on a Venn diagram of three subsets as well. Then, like I said earlier, we're going to be solving WAEC and NECO questions that they have solved on a Venn diagram in the past. So we have a lot for you in this video. So I want you to don't skip the video. If you have understood set notation before, then you don't have any problem understanding Venn diagram. But if you don't understand set notation before, please visit the video we have made on set theory before. In this playlist you will see the then you can try to understand all the set notation and the terms we have on set, and so that you can understand the this Venn diagram easily. So let's jump to it. Now, what is Venn diagram? Of course, there are a lot of explanation that have been made on Venn diagram, and who invented Venn diagram. So a Venn diagram is a widely used diagram style that shows the logical relation between sets, then popularized by John Venn in 1834 to 1923. That is in the 1880s. So basically what we have here is that in Venn diagrams we use diagram to represent a set, a particular set. Now, if you look at the previous set notation we have talked about, we didn't use diagram in that. We use a letter to represent a set, another letter to represent another set. Then we now perform different logic on those sets named. Then we use U or E to represent universal sets. Then we can now carry out different techniques, different logical question on those sets. But when it comes to Venn diagram, instead of we using labeling our set with alphabet, we use diagram. That's what a Venn diagram is talking about. We use a diagram to represent the set. So, and we are going to be talking about that briefly on how we use Venn diagram. Now, having understand what we have here, you can just go through it, and we are going to be defining them one after the other now in the next slide. Now, when it comes to Venn diagram, I told you are going to be using diagrams, pictorial representation of sets. So when it comes to Venn diagram, anytime you see this rectangular box, this rectangular box you are seeing on the screen right now, it represents universal set. So anytime you are drawing Venn diagram and you want to talk about the universal set, that means you are going to draw a rectangular box. So anytime you are talking about universal sets in Venn diagram, then we use rectangular box to represent it. In the other set notation we have talked about before, we use U or E to represent a universal set. But when it comes to Venn diagram, we use uh, rectangular box, as you can see on the screen right now, to represent universal set. So in the subsequent question you are going to be seeing on the screen, anytime you see this box, you should be able to give interpretation to it that it represents universal set. I hope you understand that. Now, then all the elements in the universal set will be inside the box. Let's say I have universal set U now, having 1 to 10 as the element in it now. Then that means all the elements 1 to 10 will be inside this universal set, inside this box. I hope you understand that now. Now let's continue. Now, having talked about universal set being represented by the box, then all other sets except universal set, we use circle to represent them. Let's say I have set A. I will use a circle to represent set A. Let's say I have set B. I will use another circle to represent set B. Let's say I have set C. Another circle will represent set C. So technically in Venn diagram, we use circle to represent set that is not universal. But we use rectangular box to represent universal set. I hope you can differentiate between that now. In the universal set, we use box to represent universal set. Then any other set that is not universal set, we use circle to represent them. So you can have a lot more than you can have different sets given. Let's say set B, set A, set B, set X, set Y, set P, set Q. Different set can be given, so we use circle to represent them. So all the elements of that particular set given will be inside the circle. Let's say I have set A now, having A, B, C, D, E, F, G as the element in that set A. Then all those elements will be inside this circle. I hope you understand that now. So you should be able to differentiate between universal set and a given set in Venn diagram. So if that is understood, let's continue. Now, if you look at this diagram we are having on the screen right now, you should be able to interpret the diagram. You should be able to interpret this diagram now on the screen. Now, on the board, we have the Venn diagram of one subset, rather, sorry, a Venn diagram of one subset. Now, if you have listened to the video we made on set before this Venn diagram, we have talked about what subset is all about. Set A is a subset of set B if all the element of B is in set A as well. So that means set B is a subset of set A. So if you don't understand that, please go back to go and watch that video so that you understand the meaning of subset. Now, if you look at this diagram now, we have this rectangular box which represents the universal set. Then inside the rectangular box, we have a circle which represents a set. And now we name that set A. So we have a universal set and we have a set A inside the universal set. What can we say about it? We can see that this set A, which is represented by this circle, which is blue, is inside this universal set. It means that all the elements in this set A is also in the universal set, because you can see that that circle is inside the rectangular box. So that means set A is a subset of what? Universal set. I want you to understand it clearly. We are having a rectangular box which is talking about the universal set, and inside the universal set we have a set A which is represented by this circle, blue. Now you can see that this set A is inside the universal set. So that means set A is a subset of universal set, because all the elements in set A are also in the universal set, because you can see that this circle is inside the universal set. So we can say that set A is a subset of the universal set. I hope you understand that now. So if I have another set B that is represented by another circle, and the circle is inside this universal set, that means set B is also a subset of universal set. But if I have another set C which is outside the universal set, that means set C is not a subset of universal set, because it is not inside the box. That means all the elements of that set C will not be inside the universal set as well. So I hope you understand that now, that set A here is a subset of universal set, because this circle which represents set A is inside the rectangular box which represents the universal set. So that makes set A a subset of universal set. If that is well understood, let's continue. Now, if you can see now that we have another box which represents universal set. Now we are now having two different sets inside the universal set. Set A, then set B. Now, set A is labeled this black circle, then this blue circle represents set B. Now, what can we see? We can see that both set A and set B are inside the universal set. Can you see? They are both inside the universal set. That means set A and set B are subset of the universal set. I hope you understand that. Set A and set B are subset of the universal set. That means their elements are also inside the universal set. So, but you can see that there is no intersection between set A and set B. What do I mean by that? Set A and set B are not joined together. They did not overlap. They did not overlap. They are not joined together. That means there is no intersection between them. So this is two subsets of the universal set without intersection between the two subsets. So now we have set A and set B, which are subsets of the universal set. Then, but there is no intersection between set A and set B. So that's how you can interpret this diagram you're having on the screen right now. I hope you understand that. Also, another diagram on the screen right now, we have uh, this rectangular box also, which represent the universal set. Also, we have set Y and set X. So set Y is represented by this yellow circle, you can see. Then we have set X, which is represented by this blue circle, as you can see on the screen right now. But you can see that both of them are subsets of the universal set. Or why? Because they are both inside the rectangular box which represent the universal set. So that means they are both subsets of the universal set. Another thing you can see is that the two circles, they overlap. They overlap. That means there is intersection between set Y and set X. That means set X and set Y have something in common. They have some common elements. So, and those elements will be here. That's where they are going to be. I hope you understand that now. So, both set Y and set X has common elements, and that's those elements, and that's the reason why they overlap like this, and that's those elements will be here. I hope you understand that now. Then, if that should be the case now, let's move on. Then, how do we get complement of a set in Venn diagram? Also, we are talking about complement of set in set notation. How we can find when we have a set, and how we can find its complement. And in that video I told you that there is no complement of a particular set without universal set. There must be a universal set before you can find complement of a set, because complement of a given set is those elements in the universal set that is not in that set. The complement of a set A are the elements in the universal set that is not in set A. So that's how to find complement of a set. But let's find the complement of a set in Venn diagram now. Now you can see that this rectangular box is the universal set, as you know. Then we have a set B, which is represented by this circle, as you know by now. Then the the complement of set B, which are the elements inside the universal set that is not inside the set B. The element in the universal set, that's what is colored by this yellow. They are the complement of set B because they are inside the universal set, but they are not inside the set B. So if I want to find the complement of set B now, that means any element outside this circle but inside the box is the complement of this set. I hope you understand that now, that the complement of this set B are the elements that are inside the universal set, which is this box that with colored yellow. Then that is not in the set B are the complement of set B. So if I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inside this box here now, then that means I can easily list the complement of set B with those elements. I hope you understand that now. So that means the complement of set B are the elements inside this colored box, as you can see, but not inside this circle. I hope you understand that now. Now, if you understand that, let's move on also. Then, also, when we have two subsets which are intercepted of a universal set, in a Venn diagram, when we have a complement of a set and we now have two subsets of the universal set, and those two sets are intersected, or they have intersection, they have common elements, then there are some things we can get from the Venn diagram. And I want you to understand this now, so that whenever we want to solve problem, you understand what you are doing easily. Now we have the universal set, and we have set P and set Q, but set P and set Q are intercepted, which is this place right now. Now this place that we paint that we colored yellow, what does it mean? It's the simple interpretation you can give to it represent P only, element in set P only, element in set P only. This side also here, I'm not talking about the whole circle Q, no, talking about this side now. It's talking about the element in Q only, element in set Q only. Now, how can we see this? How can we understand this? What I'm trying to say now. Don't forget that the whole circle here represent the set P. The whole circle here represents set P. Are you there? Now, let's say set P has element of 1, 2, 3, 4, 5. Set P has element 1, 2, 3, 4, 5. That means all the element 1, 2, 3, 4, 5 will be inside the whole circle. Are we there? And let's say we have set Q also having let's say 1, 8, 9, 1, 8, 9. So set P has 1, 2, 3, 4, 5, and set Q has 1, 8, 9. You agree with me that set P and set Q have something in common, which is 1. So that means that 1 will be in this place, this place here where they intercepted. 1 will be here. Then the element that will be in this P only will be those elements that is left when you remove the intersection from the set P. Don't forget that I said P has 1, 2, 3, 4, 5. So the intersection between P and Q is 1. So I remove that 1. That means whatever I have here, I will remove it from the element in P. So that will give me P only. So if I remove 1, that means I have 2, 3, 4, 5 left. So that means 2, 3, 4, 5 will be in this place colored yellow. That's why we call it element in P only. Element in set P only, that is not in Q. So those elements will be here. Also, the element in Q only, that is not in P, will be that will be here. Don't forget that set Q has 1, 8, and 9. So if I remove 1, 1 is already here. 1 is already pardon me, please. 1 is already here. So what do I have left in Q? I have 8 and 9 left. So 8 and 9 will be here. So that represents Q only. I hope you understand what I'm trying to say now. So, and how can we write that in set notation? You can write that P intersection Q complement. P intersection Q complement. That's talking about P only. What do you mean by P complement? Q complement. Q complement means that element in the universal set that is not in Q. So if you look at this set Q, look at the circle of set Q now. That means I'll remove this circle. So what do I have left here? I have this one left here. That's what it means. Q complement means I should remove all the elements in the Q. I hope you understand that Q complement means that all the elements in the universal set but not in this Q. So I'll remove this Q now. What do I have left? I have this colored side left. So that's why we have a P intersection Q complement means P only. Also, if I want to write this Q only now, I can say Q intersection P complement. So that means I will remove this P away. Then what I have left is this place only. I hope you understand what I'm trying to say now. So P, this colored place mean P only. That is all elements in set P only. So how can we get that? Is by removing whatever they have in common, remove it from the element in P. That means the remaining element will be here. To get Q only as well, remove whatever they have in common, remove it. Then the remaining element you have in Q will be here. I hope you understand that now. So before we continue what we are talking about the Venn diagram and how we can understand Venn diagram. Sorry for the sound you are hearing. It is a festive period, and they are throwing banger where close to where I live. So that's why you are hearing this sound, and that will not stop us from doing what you are doing now. So please, if you have not subscribed to this channel, please click the subscribe button right now so that you will be notified, and also you can click the bell button as well as we progress in this video, which is the how we can help ourselves to understand Venn diagram. So we are still talking about the Venn diagram of two subsets right now, and we are trying to understand bit by bit components of the Venn diagram. Let's continue also. Now I've already told you what this place represents. It represents the intersection of the two subsets. So set X and set Y. So any element they have in common will be here. So and that you can write down as X intersection Y in set notation like this, X intersection Y. So all the elements they have in common will be here. Let's say I have set X to have element of A, B, C. Then set Y has the element of C, D, E. You can see that they have something in common. We have an element which is common to them, which is C. So that means C will be here. Then the rest of elements in X will be here. The rest of the elements in Y will be here. I hope you understand that. So this, anytime you see this in this place, this color place, which is talking about the intersection between the two given subset of this universal what set. Also, we are still talking about the component of the Venn diagram. Now look at the diagram you see on the screen right now. You are talking about the union of two subsets in a Venn diagram. Now we have the inverser set and we have set P and set Q, and they are intercepted. Now if you look at we color this whole diagram blue, and the all this the space that is colored represent the union of P and Q, the union of P and Q. So that is, you have to combine all the elements in P and Q. That is what the whole shaded portion here represents, P union Q. Of course, if you know set notation very well, you know what union is talking about. You are to unite the element of the given set without repetition. So, or if you are looking for P union Q, that means you are looking for the elements here plus the elements here plus the elements here. Combine them together. Let's say I have 1, 2 here, I have 3 here, I have 4, 5 here. So that means P union Q will be 1, 2, 3, 4, 5 as the elements in there. So when you're talking about a Venn diagram, if you are looking for the union of these two sets, that's talking about all the elements here, the elements here, and the elements here together. I hope you understand that now. Then also we can also find a complement of the intersection as well. Complement of the intersection of two subsets. Now that is talking about, of course, you know that this place is talking about intersection between set A and set B. So, but every other element aside what you have here means that they are complement of the A intersection what B. All the elements in the color in this area that is colored represent A intersection B complement. That is, A intersection B complement is not A intersection B is not part of the elements in this colored portion. A intersection B is not part of the element in the colored portion here, as you can see clearly. So this place is white, so the rest are colored. So all the elements here are A intersection B complement, because A intersection B is not part of the element in the colored area. I hope you understand that now. So if I'm looking for intersection B complement, that means I'm looking for all the elements in the inverse set except the element in the intersection. I hope you understand what you have done there. Also, if you continue as well, then we have this all spaces, all this space colored blue, and we have set A and set B inside the inverse set, and they are intersected. So you can see that this portion and this portion and this portion is not colored, it's white. And you know what this portion and this portion and portion represent? It represents A union B. Then if you are looking for the element in the colored area, the element in the colored area here, that one will represent A union B complement. So that means those elements here, but they are not here. That means A union B need to be removed to get all the elements here. So, and that's talking about A union B complement. Those elements in the universe set, those elements in the universe set, but that is not in A union B, is A union B complement. I hope you understand that as well. So all the elements in this colored area represent A union B complement, because all the elements here, and here represent A union B. So all the elements here are not part of it, but the elements here that is in the area in the region that is colored is A union B complement. I hope you understand that as well. Let's continue. So far you have been able to understand the component of Venn diagram of two subsets. So we are going to be putting them into work now, putting all the bits that we have learned so far into practice, and we are going to be using them to solve some basic question. And I trust I want to assure you that they are very simple, and they are things you can work with, and they have interpretation, they are meaningful, so you don't have to see them as an ambiguous or something that is imaginary or abstract. They are meaningful, like I've been explaining so far. So let's look at the first question you have here. The example says that from the diagram below, sorry for that. From the diagram below, list the element of A, the element of E, which represent this universal set. It is tag E. Element of set A, B, A complement, B complement, A union A intersection B, A complement union B complement, A complement intersection B, then A union B complement. We are going to be listing all these elements in this given set using this Venn diagram. Now, before you even go there at all, you should be able to interpret this diagram as well, just based on what you have done so far. You can see that this box represents something which is the inverse set, and the inverse set is talking about is tag E, and that's talking about all the elements in the box that represent the inverse set, because don't forget that this box represents the inverse set. So all the elements you can see in the box represent the inverse set. So now that then that means if you are looking for this E here, the first question here, E, which is inverse set, that means you have to list all the elements in the box. So as you can see, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10. All these elements are inside the box. So that means the element in inverse set is from 2 to 10. I hope you understand that now. All the elements inside the box are part of the element of the inverse set. Are we there? So then let's go to B, set A. We have to list the element in set A. So let's go to set A. Don't forget that this circle represents set A. This circle here represents set A. So all the elements inside that circle belongs to the set A. All the elements in that circle belongs to set A. So what are the elements in set A? We have 2, because if you look at that circle round, trace that circle round, you have 2, we have 3, you have 4, we have 5, you have 6. So we have 2, 3, 4, 5, 6 as the element in set A. But this element here belongs to A and B. But this element here belongs to A only. This element here belongs to B only. So if this element here belongs to set A, then how do we get only is by removing whatever we have here from A. That will give us A only. This element here belongs to B only, and all the elements inside this circle here belongs to set B. So this is B only. This element that belongs represents B intersection A. So if you want to get B only, remove what they have in common from all the elements in B. That will give us B only. So we are not doing that for now. We are going back. We are coming back to that. So we are looking for the element in set B as well, which is question number C here. So look at the circle of B. So can you see the element that is there? If you can see it, pause the video and list it yourself. Then after listing it, then you cannot compare the answer. So I hope you have done that now. So if you want to crochet, let's crochet together. This, look at the circle. We have 2, we have 4, we have 7, we have 8. So those are the elements in set B. 2, 4, 7, 8. Now let's go to question number D, A complement. You have to list the element of A complement. Don't forget that element of A complement are the element in the universal set. Element in the universal set that is not in set A. So what do? Remove this set A remove this circle of A, remove it, or do as if it is not there. We are looking for the element of A complement. So which is the element in the universal set but it's not in set A. So this is set A here, remove it completely. When you remove it completely, what do you have left? Look at it. If you remove this set A like this now, so what do you have left? We have 7, we have 8, we have 9, we have 10. That's what you have left. So that means that is the element in A complement, the element in the inverse set that is not in set A. I hope you understand that now. So that means we have 7, 8, 9, 10. Also, we are looking for the element of B complement. Also, that means the element in the inverse set that is not in set B. How do we get that? Remove this set B also, then you will get its complement. Remove this set B. When I remove it, you can also pause the video also to get the answer yourself. Remove this set B now. Then whatever you have left is the B complement. Then what would that be? That means you have 3, you have 5, you have 6, you have 9, you have 8. So you have 10 rather. We have 5, we have 3, we have 5, we have 6, we have 9, we have 10. So that will be complement is 3, 5, 6, 9, 10 as the element in it. I hope you understand that as well. Then question number F, which is A intersection B. That is the what set A and set B have in common. That intersection. And you know where you can find that. This is all the element that is here. So the element that is here is your A intersection B. Also, so and that is you have 2, 4 as the element intersection of intersection of A and B. Then question number G, we are talking about A complement union B complement. A complement union B complement. That is what the question is all about. A complement. Now let's see that in action. A complement union B complement. If I look at A complement, if I find A complement now, I will remove A. If I remove this set A now, sorry, go back. Don't forget, you can always use this to this. You have already gotten the complement of A. You have gotten the complement of B as well. You can just unite it. You can just find union of this, and that will give us. You have to. You are going to list all the element of this and this without repetition. So that will give us the A union B complement. But I don't want us to do that from here. I want us to use the diagram to do it. A complement means I will remove set A. Then whatever I have here, that means I have 7, 8, 9, 10 left. I will write that. Then also B complement, I will remove set B. Then whatever I have left, I will write that as well. I have 3, 5, 6, 9, and 10. So then I will now unite it. I will combine it together to give me A complement union B complement. And that will give us 3, 5, 6, 7, 8, 9, 10 as the element in there. I hope you understand that now. If I find A complement, I will remove set A from there. I have 7, 8, 9, 10 left as the element in it. If I find B complement, I will remove set B as well. Whatever I have left is B complement. That will be 3, 5, 6, 9, 10. Then I will now unite those two elements I've gotten, and that will give me whatever I have here. I hope you understand that now. So the next question is talking about A complementation B. A complementation B. I hope you understand this interpretation of this one. If you do, I want to give you kudos because I've already explained that before. A complement. This is a complement. If I remove A complement is this. So intersection B. So intersection B, which is what you are having here, and this you can regard as what B only. Element in set B only. This question is talking about element in set B only. So A complement, which is the element in the universal set that is not in A, the intersection B, which is 7 and 8. So that means the question, this one is asking us the element in set B only. Set B only, element in set B only, which is 7 and 8. Not element in set B. No. Element in set B is 2, 4, 7, 8. But the question is asking us element in set B only, which is set 7 and 8. I hope you understand that now. So if I should write A intersection B complement, A intersection B complement, that means you should understand that one as well. This B complement, that means I should remove set B. Then whatever I have in the inverse set, then intersect it with the element in A. So that will give us 3, 5, 6. That's talking about also the element in set A only. I'm just trying to give you another question which is not part of the question given to us here. So the last question here, you have to find A union B complement. A union B complement. Now, that means what do you do? Find A union B, then remove it from the in inverse set. So A union B is the element combination of the elements here, this and this. So that is A union B. Then complement, that means the element in the inverse set that is not in A union B. So which is what? 9 and 10. So that means you're talking about elements in this inside the inverse set that is not here. So that is 9 and 10. I hope you understand this question very well. It's very simple based on what you have discussed so far. Let's see another question also. Now, if you look at the question on the board or on the screen right now, it says that the Venn diagram shown below illustrates set R and S, which are subsets of the inverse set E. Write down all the elements of the following: E X R X R intersection S, R union S, then R complement. Now, the first one, if you, of course, you should be able to interpret this diagram as well. The box represent the inverse set, which is tag E. Then we have a set R and set S, but there's no interaction between set R and set S. So they have their element, There's no connection between them. They don't have common elements. So if you are to list the element of the inverse set, that means all the elements inside the box are the element of the inverse set. And what are they? We have 1, we have 2, 3, 4, 5. Do we have 6? Excuse me. Oh, I'm looking at it truly. So that means there is an omission. There is no 6. There is a mistake here. There's no 6 in the inverse set. So that is a bug from our side. So we have we are talking about the inverse set now of this Venn diagram. So we have 1, we have 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So that means we have all the elements from 1 to 16, but minus 6. So 6 is not there as the element in the universe set. I hope you understand that. So then the next question is element in set R. You can see that means all the elements in the circle represent set R. So as you can see that we have the 2, 3, 5, 7, and 9. So also we have question number C, element in set S, which you can list. You should be able to list that now. That will give us 11, 13, and 15. Then element in R intersection X. R intersection X. You can see that the two sets are not connected. They did not intercept. So that means there's no element in there. So that means the dark set is empty. So that's why we have R intersection S to be empty. Then also we have R union X. R union X. Of course, now by now you should know what union means. You have to combine the element of R, set R and set S without repetition. So that will give us 2, 3, 5, 7, 9, 11, 13, and 15. So that will give us the element of R union X as well. Then the last question, you have to find the element of R complement. R complement. So that means I'll remove set R. Then every other element in the universe set is R complement. So by removing set R, then every other element that is left in the universe set represent uh, R complement. So we can list that as a 1, 4, 8, 10, 12. We have 13, 14, 15, then 16. And that gives us the element we have here. So I hope you understand this as well. It's quite interesting and simple if you understand what you are doing there. If you don't understand, please go back and check what you are doing. So the next question now is what you are having here. The Venn diagram below represents a universal set E of integers and its subset P and Q. List the element of the following set. So we have on figure 1 P union Q, on figure 2 P intersection Q, on figure 3 P union Q complement, on figure 4 P intersection Q complement. And this is a Y pass question for 2000 question number 3B there. So, and it's very simple as well. If you can interpret it, we have a universal set represented by the box, and it is named E. Then inside the universal set, we have two subsets, P and Q, then which are intercepted. So, constantly we should list the element of P union Q. P union Q. By now, you should be able to find that using the Venn diagram. P union Q means that you have to combine the elements here and the element here and the element here. That's the P union Q. Combine them together. So that means you have 0, we have 2, we have 3, we have 4, we have 6, we have 7, we have 8. So that means you have 0, 2, 3, 4, 6, 7, 8. That is P union Q. This plus this plus this. That's the element in P union Q. Then the next one we have to find P intersection Q. That means what the set P and Q have in common. That's their intersection. What they have in common, and you know that that one is always in this place. What they have in common, and that is what 3 and 7. So we have 3 and 7. Then also we have to find P union Q complement. Please, before you do this, you can pause your video now to try this question. P union Q complement. So that is the element in the universal set that is not in P union Q. The element in the universal set that is not in P union Q. The element in P union Q are the elements here. So remove this one from it. Remove it. So whatever you have left is P union Q complement. And that will give us a 1, 5, then 9. 1, 5, and 9. That's the P union Q complement. I hope you understand that. Then P intersection Q complement as well. You might need to pause your video as well and try that one yourself as well. P intersection Q complement. So that means in P intersection Q need to be removed. Remove P intersection Q. This P intersection Q. Remove it. Then whatever you have left is P intersection Q complement. Remove P intersection Q. This P intersection Q. When I remove it, what do I have left? I have a 0. I have 1, 2. I have 4. I have 5. I have 6. I have 8. And I have 9. So P intersection Q complement is that remove P intersection Q, which is this place. Then whatever you have left inside the box is the P intersection Q complement, which I believe you understand how we do this as well. So don't forget, we are still solving a question on Venn diagram of two subsets, and I believe the question have been so wonderful so far, and you understand them. If you don't, please you may need to rewind the video and listen to it very well, and I believe you will understand them. So it is possible as well that you'll be given some sets. Let's say set A, set B, and set C, or let's say set A and set B now. Then they now ask you to use those two given set to draw a Venn diagram as well. You can do that as well. So instead of giving you a already prepared Venn diagram to now use to solve problem, they can also give you some set. Then they now use it to draw a Venn diagram. It's very good. It's going to be simple. It's simple as well. Then look at if you are given two sets, so a two subset now of the inverse set. Then draw the draw the inverse set, which is the rectangular box. Then the two subsets given to you, look at them. Do they have anything in common? If they have anything in common, so that means you draw two circles, then intercepted, then label the two circles with the name of the set given to you. Then whatever they have in common, remove it first. Then you put down in the intersection. Then whatever they have in common, remove it from the first set. That will give you the remaining element that will be in P only. Then whatever they have in common in the second set, remove it. Then the whatever you have left, that will be in this set Q only. I hope you understand that as well. So it's possible they give you a set like this now. They now have to use it to draw a Venn diagram. It's possible as well. So please let's go to the next question we have. Now we have been looking at solving question now, giving some elements, or using interpreting a Venn diagram. But it's possible you are giving a question on two subsets, Venn diagram of two subsets, and in word problem form. Now you can be given also a word problem that in Venn diagram that belongs to two subsets, and we are going to start seeing that now. But that can be solved in two ways. There's a formula for solving that, and you can also interpret it using Venn diagram. So we're going to solve it in two ways as well. So the example of what I'm saying is what you have seen on the screen right now. In a class of 30 students, in a class of what? 30 students. That means the inverse set is what? 30. That means you have 30 elements in the inverse set, and the elements are students. So that means in this rectangular box, that means you have 30 students there, which is represent the element in the inverse set. I hope you understand that now. 25 like balls. So 25 like football. That means there is set football represented by this circle, and there is 15 like wrestling. That means there is another set called wrestling, which is represented by this circle as well. So you can see that we have F, which represent football. We have W, which represent wrestling, and in football we have 25 students there, and we have in wrestling we have 15 students who do wrestling, and there is 25 students who play football, and all the students in the inverse set are 30. Then every pupils like at least one of these sports. That means all these 30 students are doing one or two things. They are either playing football or they are doing wrestling. So nobody is idle. Nobody is left in the inverse set that is not doing anything. I hope you understand that now. That's what this statement means. So how many students like both sports? That means how many students will be here that likes both sports? I hope you understand that now. How many students like both sports? So they want us to find the elements that are here. Then how do we interpret this question? Since we don't know the number of students that like both sports, then we can represent it with a variable. Here we say number of students of F intersection W is equals to X. Number of students that like both football and wrestling is X. So that means you have X here. I hope you understand now. So then how do we not get people that like football only, which is represented by this place? Don't forget, let's say I have in the number of students that like football are 25. That means all the elements here are 25 in numbers, just like what you have been doing before. All the elements here are 2 0 2 8 7 3. So also here, sorry, all the elements in this football as a set are 25. Then we know that people that like both are X. Don't forget here, all the elements in set P are 20873. So to get people that are here is by removing what these people that are here, remove it from the element in P. That will give us people that are here. So if you remove 37 from the element in P, that means you have 028 left. So also, to know people that are playing football only now, that like football only, that means you need to remove people that that like both football and wrestling from 25 here. You need to remove people that like both football and wrestling from the 25 element in football, and that give us 25 minus X. So 25 minus X like football only. I hope you understand what you are doing there, please. Also, to get people that like wrestling only, don't forget that people that like wrestling are 15 in numbers. All the students in the wrestling are 15 in numbers now. And the people that love both football and wrestling and X. So remove people that love both from 15. That will give up people that love wrestling only. I hope you understand that. So to get people that are here, that may be 15 minus X as well. I hope you understand that now. Then the union of this and this will give us what? 30. I hope I hope you understand that now. Since there are no people idle, no more people are idle here. So that means the union of football and wrestling should give us what? 30. So that means this plus this should give us what? 30. So from there we'll be able to find the value of our what? X. So that means we have 25 minus x plus 15 minus x equals to what? 30. The union of every year and year should give us what? 30. Then if you simplify that further, we have 25 plus 50, that gives us 40. Minus s plus s will give us 0. Then 0 minus s will give us minus x is equals to 30. Then collect light term as well. We have take 40 to this side. We have minus x is equals to 30 minus 40, and that will give us minus 10. So minus will take care of minus. That means we have our s to be equals to 10. So we have 10 students that like both sports. So that means we have 10 here. So if you want to know how many students like football only, that means you have 25 minus 10. That gives us 15 like football only. And if you want to know people that students that like wrestling only, that will be 15 minus 10 as well. That will give us what? 5. I hope you understand that this question as well. But this question also can be solved without drawing the Venn diagram as well. You can solve it without drawing the Venn diagram using the formula for solving it. And this formula is only possible if there are no people idle in the inverse set. And this is the formula. Now this is the second method I write here. And this we are still having the same question in a class of 30 students. 25 like football, 15 like wrestling. Every pupil like at least one of these sports. How many students like both? I write here, let F represent football and W represent wrestling. There is a condition for using this formula we have here. The condition is that there must not be any student that is idle or any element that is idle in the inverse set. The formula below will work only when no element in the inverse set in the inverse set is idle. That is, no element is left out in the inverse set. That's only when you can use this formula. Let's go back. Let's say there are some students that does not like football and the wrestling. That means those students will be here. They will be inside this box here, outside the circle. So in that case, if you want to find our x, that means you have this plus this plus this plus those students that are idle. So that will give equals to 30 here. That's when you will be able to find value of our x. But in this case, this formula will only be possible when no student is idle in the inverse set or no element is idle in the inverse set. That's why you can use this formula. And what's the formula? We have the number of F union W. All the elements here, number of F union W is equals to number of elements in football plus number of elements in the wrestling minus the interaction between them. So number of F union W, which is 30, you have been given that this is 30, is equals to number of elements in F, which is 25. The number of elements in W, which is 15, equals minus number of elements in F interaction W. That's what we are looking for. So the reason why we are having F and W here is because of what we are given in the question. In another question, it could be another variable. So, but this is the formula, this is the format for the formula. This is how it's going to go. So, if I have, let's say I have X and Y in the question, I will have S union Y is equals to number of X plus number of Y minus number of S intersection Y. So substitute your value in there, then you get your answer. So N number of F union W is 30. that is all the no students in the class 30. The number of elements in set football is 25. Number of elements in set wrestling is 15 minus number of elements in the that like both, which is F intersection W, which is what we are looking for. So we have 30 is equal to 25 plus 15 minus this. Then 25 plus 15 is 40. Then collect light time. This one comes if you this one comes here, you have 30 minus 40 equals to minus this. Then 30 minus 40 will give us minus 10. Then minus will take care of minus. Then we have a number of elements in F intersection W, which are this number of students that like both is equals to 10, which is what we got here as well. And you can see that the formula still work only because we did not have students that are high do in the universal set. So if there are students that are high do in the universal set, that means you are going to use this Venn diagram to solve the question. You cannot use this formula. I hope I'm cleared enough. So that's the solution to the first question on word problem in Venn diagram of two subsets. Let's go to another question. Now let's look at this question now on the Venn diagram of two subsets. 30 pupils are asked what colors of shirt they like to wear. That means we have 30 30 elements in the universal set, which are pupils. So then 20 says blue. So that means we have set blue, which have 20 elements in it. Then 15 says pink. That means we have set pink as well, which has 15 elements in it. And 5 do not like either of the colors. So that means we have 5 elements that are idle, that are inside the universal set, but they are not in, they don't like blue and they don't like what pink. That's why they are outside. You can see that we have 5 here. I hope you understand that now. Show this information on the Venn diagram and hence find the number of pupils who like to wear both shirts, then only one of the two shirts. So now, since we are not giving the number of students that like both blue and pink, which is this place as well, what do? You can represent it with a variable. So B intersection P, look at that B represent blue, P represent pink. So B intersection P, this is the element that are here. So we don't know it, and that's why we have to find it here. So we can call it X. So if there are 20 elements in a set blue, and we already know people that are all that are in that like both blue and pink, which are X, then how do we get people element that are here which represent blue only? By now you should know how to get that. That will be number that the element that like both minus people that are inside blue as a set 20. So that we have 20 minus X here. That will give us 20 minus X. Also to get pink only, which is here, that will be 15 minus X as well, which by now you should know how we got that as well. Then from there we can now find the value of our X. Then don't forget that the union of this the union of blue and pink, which is this and this and this, then plus people that are hydro here will give us what 30, because the universal set here represent what 30. So everything that universal set should give us what 30. So this plus this plus this plus 5 will give us what 30. So that we have a 20 minus s plus x plus 15 minus x plus this 5 is equals to 30. Then from there we can collect like times. 20 plus 15 will give us 35 plus 5 will give us 40. Minus x plus x will give us 0. Then 0 minus s will give us minus s is equals to 30. From there we can collect like time. 40 comes here. We have minus x equals to 30 minus 40. Then that will give us minus 10. Cancel both sides. That will give us s to be 10 pupils. So that means 10 pupils like both blue and pink as colors. So that means x here will be 10. Are we there? So that means if you want to get people that like blue only now, all the students that like blue only, that means you have a 20 minus 10, that gives us 10. To know people that pupils that like blue only, purple only, or sorry, pink only rather, which is 15 minus s. So that will give us 15 minus 10. That will give us what 5 as well. So we have gotten people that like both shirts, which is people that are here, which is 10. The question says we should find only one of the two shirts. Only one of the two shirts. We are looking for people that like only one of the two shirts. Where are these two people that like only one of the two shirts? Where are they? They are here and they are here. These people that are here, they like only one shirt. People that are here, they like only one shirt. So this one like only blue. This one like only what? Pink. So that means you have 20 minus s plus 15 minus s. 20 minus s plus 15 minus x. Collect like time. 20 plus 15 give us 35. Minus s will give us what? Minus 2x. So the x is 10. So we have 35 minus 2 into 10. 2 times 10 give us 20. 35 minus 1 give us 15 puppies. So that means 15 puppies also like only one shirt. Does that make any sense to you? It does. So it's very simple. It's very, very simple. And I hope you are enjoying it. Let's go to the next question, please, without wasting much of our time. Now look at this question. This is a Y pass question as well. And it is very interesting on Venn diagram of two subsets as well as we have been solving so far, which I believe you have been enjoying and you have been you understand everything you have been doing so far. Excuse me. So we are solving more questions during 1 year in a school. During 1 year in a school, that means the universal set is 1. The universal set is 1. So out of the 1 year, 5/8 of the students had measles. In that 1 year, 5/8 of the students had measles. 1/2 had chickenpox. So that means the universal set we have 1. Then inside the universal set we have two different sets. One is measles, which is represented by M, and the other one is chickenpox, which is represented by C. Are you there with me now? So how many students has measles? 5/8. How many students has chickenpox? 1/2. And 1/8 had neither. So that means there are some students that did not have any of these diseases. So, and that means they are going to be here outside this measles and chickenpox, but inside the universal set. So we have 1/8 here. They don't have any disease. What fraction of the school had both measles and chickenpox? So that means you are looking for the interaction between measles and chickenpox. So which we can represent with a variable x. So if you know that x has both disease, measles and chickenpox, then how do you know people that has only measles only? How do we know student that has measles only? That would be number of element in measles minus number of element that has both measles and chickenpox, which is x. So we have 5/8 minus x. Also, to know student that have a chickenpox only, which is people that are here, that would be number of element in chickenpox minus people that have both disease, so which is x. So they have half minus x. So now then the combination, the addition of this plus this plus this plus people that are idle will give us what? 1. So we have 1/8 minus s plus x plus half minus s, then plus 1/8 is equals to what? 1. Then from here now we can collect like times. So first and foremost now we can find the LCM of 5/8 plus 1/2 plus 1/8. And that will be LCM of 8, 2, and 8 is 8. So 8 in 8 is 1. 1 times 5 give us 5. 2 in 8 is 4. 4 times 1 is 4. 8 in 8 is 1. 1 times 1 is 1. So do we have here? Then minus s plus s will give us 0. Then minus s, that we have minus s equals to 1. So 5 plus 4 plus 1 is 10/8 minus s equals to 1. Then from there you can take like time. You can reduce this. 2 can go in 10, 2 can go in 5. That is 5/4. Then take 5/4 to the other side. That means you have minus s equals to 1 minus 5/4. Collect like times in the right hand side as well. That is 4. And that will give us 4 minus 5/4. and that 4 minus 5 equal to 1 over minus 1 over 4. Then minus can take care of minus at both sides. Our s will be 1 over 4. So that means 1 over the people that the fraction of the school that has measles and chickenpox is 1 over 4, which is quite simple as well. So let's see one or two questions more on the Venn diagram of two subsets, so that we understand it better and better. Now let's see quickly. Look at this question also. In a class of all students, in a class of in a class rather in a class all the students like green color, which is represented by G, or blue color, which is represented by B, or both. If 65 like green and 45 like blue, what percentage of the student like both colors? So now in this question you can see that we did not use a Venn diagram, so we use the other formula to solve it. Of course, if you want to use Venn diagram, you can also use Venn diagram as well. There's no big deal in that, but it's easy to use the other formula. Why? Because no student is idle. All of them like either green or blue, so we can easily use the formula. Now we have to find the what percentage of the student like both colors, which is interaction between green and blue. So say we can represent that one by x. So if we rewrite the formula out, number of green union blue equals to number of green plus number of blue minus number of green interaction blue. So we know the number of green union blue. We are told because we are told that 65 like green, 45 like blue. So 65% rather. That will be 65 out of 100. So that means technically we have 100 of 100 students. What do you mean of 65%? 65% means 65 out of 100. Also 45% here means also 45 out of 100. So that means technically we have 100 out of 100 students in the school. I hope you understand what you are doing there at all. So you have 100 here. So G in B is 100. The number of elements in green is 65. Number of elements in blue is 45 minus the interaction between them. Collect like time. 65 plus 45 is 110 minus x. Take like time as well. 110 comes here. You have a minus x left equals to 100 minus 110. That gives us minus 10. So minus take your minus, then s is 10. So that means 10% of the student like both colors. 10% of the student also like both colors. So I hope you understand the question as well. If you want to use your Venn diagram at all, so you draw your box, then in the inverse set you have your E to be equal to 100, then you have circle for green, you have circle for blue, then you have 65 as the element, all the elements in green, 45 as all the elements in blue. Then in between, in the interaction between them, you have x. So we have 65 minus s. Then we have 45 minus s. Then that will be 100 equals to 65 minus s plus s plus 45 minus s. Then collect like times, you get your s to be 10 as well. So it's quite simple as well. Let's go to the next question. The next question is also a WAEC pass question. That question number WAEC 2006 question number 4A. WAEC 2006 question number 4A, which I believe you should be able to solve by yourself right now if you have been following this tutorial from the beginning. You should be able to solve this question yourself. You can just pause the video and try to lay your hands on the question yourself without looking at what you have done here. Then after you might have done that, then you can now come and cross check. Just write out the question, then come and cross check whether you are right or wrong. So which I believe you have done that now. Now let's solve it together and see. In a class of 45 students, that means a inverse set is 45. You have 45 students in inverse set. 35 offer physics. That means there's a set physics. 28 offer government. There's set government as well. So, and 12 did not offer any of the two subjects. That means there are 12 students that are idle. So that means they are inside the inverse set but not inside physics and government. So first question, draw the Venn diagram to represent the information. You want to see your Venn diagram. Then another question, how many students offer both physics and government? So we don't know them, so we can represent them by X. So that may be having X here. When you draw your, first of all, draw your rectangular board to represent inverse set, then draw a circle to represent physics, another circle to represent government, and they should intersect because we are told to find number of students that offer both physics and government, which is we call X. Then to know people that are in physics that offer physics only, that means will be 32 minus what, X. To know people that offer government only, which is this place, you have 28 minus X. The reason why we are filling this is that don't forget that we need it to find the value of our X. One. Another thing is that the question says you should draw the Venn diagram. So that means all these things must be there. If you don't fill it, if you don't fill them, that means your Venn diagram is incomplete. So you must fill them up. So you must find your fees only, that will be 32 minus X. Government only 28 minus X. You must write them like this. Then people that did not do anything, 12. So this is the complete Venn diagram you have to draw. Then from there now you can now find number of students, that over both fees and government. Then how do we do that? Then the union of physics and government plus people that are idle will give us 45 as well. So they have 32 minus S plus S plus 28 minus S plus 12 will give us what, 45. Collect light time from there. 32 plus 28 plus 12 will give us 72. Minus S plus S will give us 0. 0 minus L will give us minus L equals to 45. Collect light times, then you get your S to be 27. So that means 27 pupils or students offered both fees and government. Then if you want to know people that offer physics only, that will be 32 minus 27. Government only, that will be 28 minus 27 as well. Then, but we are not asked to find that. The next question next question says that what is number of P union government? P union government. They want to know the element, how many students offered how many students are in both physics and government, to all together. P union G. By now you should know what that represents. This represents this plus this plus this. That's P union G. This plus this plus this. People that are here, 32 minus 27. People that are here, 27. People that are here, 28 minus 27. So that should give us what you are looking for. So if you want to do that, you can do that. 32 minus 27. That will give us 5. Then 5 plus 27 here, that will give us 32. Then 32, 28 minus 27 here give us 1. So 32 plus 1 give us 33. And that's what you have here. If you don't want to do it that way, you can say this is 32 minus S, you rewrite it, plus X plus 28 minus S. Then collect light times. 32 plus 28 will give us 60. Minus S plus L give us 0. 0 minus S will give us minus S. So put your S. Your S is 27 here. You have 60 minus 27. That gives us 33. So I hope you have been able to learn one or two things on the Venn diagram of two subsets. And it's quite interesting. It is quite simple as well, which I believe you have learned one or two things from it so far. So don't forget we are solving Venn diagram on set theory, and this is the second phase on set. The first phase we have solved all the set notation, and the video is uploaded, and you can check it in the playlist of this video. And also, if you have not subscribed to this channel, please click the subscribe button right now so that you can be notified whenever we post video on this channel. And you can also click on the notification button, and as we journey in this video right now. Now, the next question we have here now is also WAEC past question, which is 2012 question number 6B, still on the Venn diagram of two subsets. A number of tourists were interviewed on their choice of means of travel. A number of tourists were interviewed. So, but we don't know the number of tourists that were interviewed. So we're only told that a number of them were interviewed. So what can we do? So that means we don't know the number of elements in the uh, universal set, since we are not told the number of tourists that were interviewed. So we can say let the number of elements in the universal set be what, x. So to third said they travel by road. To third, what meaning of to third? To third said they traveled by road. To third said they travel by road. Then 13 over 30 by here. Then 4 over 15 by both here and road. Then we have if 20 tourists did not travel by here or road. So represent the information on the Venn diagram. How many tourists were interviewed? How many tourists by here only? So let's try to look at the question one after the other again. So we don't know the number of tourists that were interviewed, call it that one x. Then two-thirds said they travel by road. So two-thirds traveled by road. That is where, so there's a mistake here. Don't know where this coming from. Two-thirds said they travel by road. Two-thirds travel by road. By road. 13 over 30 by here. So this is supposed to be two-thirds. 2 over 3. 2 over 3. Not, there's a mistake here, please. There's a mistake in this. This is 2 over 3, not 15 over 4 over 15 or 14 over 15. Two-thirds said they travel by road. R represent road. A represent here. So two-thirds said they travel by road. Two-thirds of what? Two-thirds of people that were interviewed. And people that were interviewed are x. So this will be two-thirds, which is 2 over 3x. Please help us to correct this now. That's another bug, another mistake. Why typographical error while we are typing it. So two-thirds said they travel by road. Two-thirds of what? Two-thirds of people that were interviewed. That way you have 2 over 3 times x. That will give us 2 over 3x. Then 13 over 30 by here. 13 over 30 of what? Of people that were interviewed, x. So we have 13 over 30x as well. Please, if you don't understand that, please, this is confusing. This is what is confusing us here now. Two-thirds said they travel by road. Road is 2 over 3x. By 13 over 30 by here. 13 over 30x. Then 4 over 15 by both here and road. So 4 over 15 of people that were interviewed also like both here and road. That is the interaction between here and road. Then how do we not get here only and road only? Of course, they are told that if 20 tourists did not travel by either road and here, so that means 20 are inside the inverter set that I do. So we need to get here only and road only. then it's very easy. So all the people that travel by here are 13 over 30x. So to get here only, that would be this minus people that travel by boat. So 13 over 30x minus 4 over 15x. Then also to get road only as well, that would be number of elements in the row minus number of people that travel by boat. So you can say that this is correct now. People that travel by road are 2 over 3s minus this. So that gives us people that travel by road only. Then the addition of this, and people that I do should give us the value of people that were interviewed. So that means you have this plus this plus this plus 20 will give us what? X. So that what you have here, that this which is in the bracket plus this plus whatever you have here in the bracket plus 20 will give us what? X. From there we can simplify, find the LCM, which is 30. That'll give us 13s. 15 30 give us 2 times 4 give us 8. So that gives us minus 8x plus 4 over 15x plus, you can also find the LCM here, which is 15. 3 in 15 is 5. 5 times 2 is 10. 10x minus 4x plus 20 equals to x. Then collect later, 13s minus 8 will give us 5s over 30 plus 4s over 15. 10s minus 4s will give us 6s over 15 plus 20 equals to x. Then we can multiply through by the LCM of the denominator, which is 30. So if you multiply through by 30, that will clear the denominator for us. So 30 times 5x over 30. So 30 will take care of 30, that means you have 5x left. 30 times 4s over 15. 15 in 30, that gives us 2 times 4s will give us 8x. Plus 30 times 6s over 15. 15 in 30 will give us 2 times 6s will give us 12x. Plus 30 times 20 will give us 600 equals to 30 times s will give us 30x. So we have been able to multiply through by 30, and this is what we have left. So 5s plus 8s plus 12s, that will give us 25s plus 600 equals to 30s. Collect like times. Take 25x to this side, that means you have 600 is equals to 30s minus 25x. That will give us 30s minus 25x equals to 600. 30s minus 25x give us 5x equals to 600. Divide both side by 5, that will give us 1 s to be equals to 120. So that means we have 120 tourists that were interviewed. 120 tourists were interviewed. So then, and sorry, that's the first question. Second question, how many tourists were interviewed? So that's 120 tourists. Then question number 3, how many tourists traveled by air only? How many tourists travel by air only? Where is air only? This is air only. People that are here travel by air only. So that means you have 13 over s, sorry, 13x over 30 minus 14x over 15. 13s minus 13s over 30 minus 4s over 15. So we already know our x. Our s is 120. So that means you have a 13 over 30 times 120 minus 14 over 15 times 120. So 30 will go in 120. 15 also will go in 120. So if you simplify that, that will give us 20 tourists that travel by air only. So you can also find people that travel by road only if you have to find that as well. So, and that is quite simple. You can also find people that travel by both means of traveling. That would be 4 over 15 times 120 also. So that's the question for wire 212, question number 6b as well, which is very simple as well to interpret if you look at it critically. Please disregard whatever you have here. This is supposed to be 2 over 3x, as you can see, as I've corrected also. So I hope you understand that question as well. As you can see, now you may need to take your biro and your pencil to write it down and solve it yourself again, so that you can understand it. Now let's go to the next thing on agenda. Now we have one way or the other talked about Venn diagram of two subsets. Now we are going to three subsets now. So if you understand Venn diagram of two subsets very well, then understanding Venn diagram of three subsets will not be difficult for you as well. It's going to be very simple. So because if you don't understand two subsets, then you have a prob challenge in understanding these three subsets. Now, what do you mean by Venn diagram of three subsets? Of course, the same interpretation. The box represents the inverse set, but inside the inverse set we have three subsets now: set A, B, and C, and they are all inside the inverse set. So that's why there are three subsets, because their elements are also inside the inverse set. That's why they are having these three circles inside the box. So, and also having this kind of a Venn diagram as well, we have different interpretation as well. This side represents A only, element in set A only. Don't forget that this circle here represents set A, this circle here represents set B, this circle here represents set B, set C as well. This circle here represents element in set A only, without B, without C. This element here represents A intersection B only. This element here represents set B only. This element here represents element in set A and set C only. This element here represents element in set B and set C only. This element here represents element in C only. Then this element, this plate that is colored, represents A intersection B intersection C. That is those elements that is common to set A, set B, and set what C. They will be here. I hope you understand that. So this plate that is colored represents those elements that set A and set B, set C has in common. Let's say set A has 1, 2, 3. Set A B has 3, 4, 5. Set C have 3, 9, 9. So that means all these three sets has 3 as the common element. So that means that 3 will be here. I hope you understand that now. Let's move further to know other component that we have in Venn diagram of three subsets. Now you can see all these colored places that this place that is colored in the three subsets. You can see that all the elements here, combination of all the elements here represent the union of the three sets: A union B union C. So all the elements here, that is all this colored area, represent A union B union C. So if you are looking for A union B union C, that means you need to combine all the elements in the three sets together without repetition. I hope you understand that as well. Also, if you are looking for this element here, as I've said earlier, this one is talking about element in set A only. The circle here represents all the elements in set A, but this one represents all the elements in set A only. Why? Set A might have some element that is also in B. Do you agree with me that? So set A also can have some element that's also in C, but this play represents only element in set A only. After you might have removed what they have in all the three of them have in common, remove it away. Whatever you might have removed, whatever this one and this one have in common, remove it. Whatever after you might have removed whatever A and C have in common, remove it. Then whatever you have left will be here, and that is what you have: A intersection B complement intersection C complement. Remove B, remove C. Whatever you have here is what you're having here. B complement means remove B. C complement remove C. What do you have left? You have this place left. So that is A only. I hope you understand that now. Let's see another one. This place that is green, color green. What does it represent? It represents B only. Element in set B only. Remove set A. Remove set what? C. Then what do you have left? You have this place left. That is B only now. Element in set B only. After you might have removed this place, remove this place, remove this place. Whatever you have left at set B, in B, that is B only. So and that is tag A complement, direction B, direction C complement. That is element in set B only, not element that is common to A, B, C. No, element in B only. Remove element that common to A and B, remove it. Remove element that common to B and C, which is D, they remove it away. Element that common to three of them, remove it away. Then whatever you have left in B is B only. I hope you understand that now. Then let's see the next one. Then this place as well, that is color red, represents C only, element in C only, which is A complement, remove A, B complement, remove B. Then whatever you have left is C only, element in set C only. I hope you understand that as well. Then element here means element in A in direction B only. A in direction B only is the element that is here. A in direction B but not C. So all the element that is common to A and B only but not what C. So they are here. I hope you understand that now. A in direction B only are here. Then the next one we have the elements here are element in A in direction C only without B. Element in element that is common to A and C only without B. Then the next one, this place as well also talk about elements in B and C only without what A. A, B in direction C in direction A complement. Remove A, then whatever B and C have in common, that's what you're having here. That's what is represented as well. B intersects C only. I hope you understand that as well. So then if you look at what you're having on the screen right now, you have A union B union C as this white region. Then this colored area here, what does it represent? You should be able to say what it represents. It represents the complement of A union B union C. That is those elements in the universal set that is not in A union B union C. So they are here. I hope you understand that now. Those elements that is in the universal set that but is not does not belong to A union B union C. So they are the one that is in this blue colored region. I hope you understand that as well. So that is all. Those are the components that we have in the Venn diagram of three subsets. Then if you understand that now, let's now start solving questions with this Venn diagram of three subsets as well. Now, the first question you're going to solve under this is what you are seeing on the screen right now. And it says that the set A have elements 1, 3, 5, 7, 9, 11. Set B 2, 3, 5, 7, 11, 15. Set C 3, 6, 9, 12, 15. They are subset of the universal set U having element of 1 to 15. Draw a Venn diagram to illustrate the given information. Then B, use your diagram to find this and this. Don't forget this is the question given to them. Then you are now asked to draw the Venn diagram given these three sets which are subsets of the universal set. So what do you do? For draw your rectangular box which is representing this universal set U, and inside universal set U we have 1 to 15 as the elements in the universal set. So then since we have three subsets A, B and C, what do? You draw a circle to represent set A, another circle to represent set B, another circle to represent what set C, and make sure that they all overlap like this. B is joined to A, then C is joined to B, C is joined to A as well, and three of them are joined together. So then how do we fill in all the spaces in the Venn diagram? What do? This region is what this place is what they have in common. Three of them have in common. So for look, check out what they have in common, all the three sets. they have here, you can see that this there's 3 here, there's 3 here. In C as well, there's 3. So there's no other element that they have in common. So you can see that they have 3 in common. So you put 3 here, and that's represent what the A intersection B intersection C, 3. Then this point belongs to A intersection B only. What A and B has only. What they have in common only. A intersection B only. What they have in common. So go back to A and B. Then you can see that they have 3 in common. But 3 is already in what 3 of them have in common. So you don't need to repeat 3 here again. No. Because if you look at this circle here, we belong to A. This circle here belongs to set A. So all the elements here must be everything you are having here. So if I should write 3 here and I should go and write 3 here again, that will be wrong. So 3 is already here. So then you overlook 3. Then go again. 5 is here, 5 is here. So that means 5 will be in A and B. 5 is in A and B. Then 7 is here, 7 is also here. 7 will be in A and B. Then 11 is here, 11 is also here. So 11 will be in A and B. So that means I've gotten A intersection B only. I hope you understand that now. Then I'll go to B this place which is talking about A intersection C. A intersection C only. This is A intersection C. What they have in common, they have 3 in common, but 3 is already there, so I don't need to put 3 again. I hope you understand that now. So what else do they have in common that belongs to B, A and C only? So A has 9, C also have 9. So that means they have 9 in common. So there's no other element that A and C have in common. So 9. So that means A intersection C only is 9. So having filled that now, that means we need to fill A only. Now, having gotten A intersection B, then A intersection B intersection C, then A intersection C, we have gotten that. Then we need to get our A only. How do we get that? Look at the set A. What do we have left? You have already filled 3, you already filled 5, you already filled 7, 11, we have already filled 9. What else do you have left here? We have what? 1 left. So that means the element that will be here is what? 1. So we have only 1 here that belongs to set A only. How do we get that? We remove X, remove this one from here, remove whatever you have here, remove it from here as well. Then whatever you have here, we also remove it from here. That means you have 1 left. Even if it's a word problem as well, whatever you get here, remove it from all the elements in A. Whatever you have here, remove from element in A. Whatever you have here, remove from element in A. That will give us A only. I hope you understand that now. Now let's go to uh finding this set B. Let's go back to set B now. Now set B, we need to find what we already got in this part as well. Then we need to find the B intersection C only now. B intersection C only. What they have in common that others do not have, which is 15 and they have 15 here. There's a 15 here, so that means they have 15 in common. So they have 3 and 3. That's already here already, so you don't need to repeat it again. So then having done that, then we need to get what B element in B only. Element in B only, which is element here. Then how do we get that? Look at the circle of B as well. Look at the circle of B, which has the element in B here. 2 is now let's look at it. 3 is here, 5 is here, 7 is here, 11 is here, 15 is here. What else do we not have here already? So 2. So 2 is only one that is not there already. So that means 2 will be here, and that's what we have in here, 2 in B only. So then let's go to C only now. To get C only now, what do? We go back to element of set C. You can see that we already have 3. 3 is here. We already have 6. Sorry. You already have 9. 9 is already here. You already have 15. 15 is here. Look at the circle of set C. You already have 9, 3, and 15. So what else do you have in this set? We have 6. We have 12 left. So that means 6 and 12 will be here. So that means that's also complete. So this is complete. This is also complete now. Then that is not all. So you have gotten for A, you have gotten to B, you have gotten to C. But if you look at the universal set, we have the element from 1 to 15. There are some elements that are not that are in the universal set, but they are not here. There are some elements in the universal set, but they are not in A union B union C. What are the elements? 4 is here, but there's no 4 in the A union B union C. So that means write the 4 outside the box. There is no 8 here, you write 8 here. There's no 10 here, you write the 10 out. But there is 10 in the universal set. There is 14, but there's no 14 here, you write it out. There is 13 in the universal set, there is no 13 in the, so you write it out. So you can see this is the Venn diagram you have to construct given this information. I hope you understand what you have done there. Now from then on, you now also use it to you now have to use this Venn diagram to uh solve these two questions. The mistakes many students will make in this kind of question, because this is a wide pass question, is that some of them will not go and be using set notation to go and solve this question. They will say use the diagram to find this. Don't go and use set notation to solve this. Some of them you go and say, okay, my set C is this, then I can find A complement. You will not list out the A complement, they now find the relation between them. You will be wrong. Because you should use this diagram, don't use set notation. So from the uh diagram you have to find this. So set C, this set C here, intersection A complement. Set C, intersection A complement. Set C, I'm trying to so that you can understand it now. Set C, intersection A complement. Remove A. That's A complement. Whatever you have there is A complement. Remove this A. So A is out of it. The intersection A complement C, this C, intersection A complement. If I remove this A here, what do I have left in C? I have C 12 and 15, which intercept the complement of A. So C 12 and 15 intercept the complement of A, which is whatever you have left here. So whatever you have left here intercept 6, 12 and 15. So that means the answer you are looking for is 6, 12 and 15. So after you might have removed A, because A complements means that all elements inside inverse set except A. So remove this element in A here. You have 2, you have 15, you have 6, 12, 8, 10, 4, then 15, 14, 13. Then those elements now intersect set C. Inside set C, after you might have removed it, what do you have left there? You have 15, 6, and 12. So that means the answer is 6, 12, and 15 as that. Then also A complement intersection B union C. A complement intersection B union C. A complement is remove A. Then intersection B union C. Union of B and C. This union of this and this. After you might have removed everything A, remove this A at all. Sorry, remove this A away. You have this, and this left in B union C. So that means you have 2, 6, 12, and 15. And that will give us the answer we are looking for right there. So that's the first question we are solving on the Venn diagram of 3 subsets. Let's move to the next question. Now, the next question we want to solve on a Venn diagram of 3 subsets is a word problem. It's very simple as well, and it's going. I hope I know you are going to understand it and enjoy it as well. Now let's look at the question. In a certain examination, that means we don't know how many people sat for the examination. In a certain examination, 52 candidates offer biology. So that means in a biology as a set. So that means we have a set for biology. This circle represents biology here. So we have 52 elements in it. History 60. That means another set, another circle represents history, which is 60 in set as the element in it. Then we have 96 as mathematics. So we have set mathematics represented by another circle, the 96 element in it. Now let's go on. 21 offer biology and history. 21 offer biology and history. Biology and history 21. But the question did not tell us about biology and history only. That's where the clause is. If the question were to be 21 offer biology and history only, that means we put 21 here. But the question did not say 21 offer biology and history only. So that means there's something we need to remove from this 21. Because don't forget that this place represents biology and history only. So the question only say that 21 offer biology and history. So let's leave this one first. 22 mathematics and biology. Mathematics and biology 22. Question did not say that 22 offer mathematics and biology only as well. So that means you are going to remove something from here as well. Let's go again. 16 mathematics and history. The question did not say that 16 offer mathematics and history only as well. So let's go again. You see something is coming up. If 7 candidates offer all the 3 subjects, so that means we know the interaction between the 3 of them. 7 candidates and offer all the 3 subjects. That means 7. We have 7 here. I hope you understand that now. So 7 will be here. Let's now go back to getting how many students offer biology and history only. Is biology and history only, which is this place. 21 offer biology and history. So to get people that offer biology and history only, remove people that offer the 3 subjects from it. That will give us 21 minus 7. That will give us 14. So that means 14 offer biology and history only. Also to get people that offer biology and mathematics only, which is this place, we are told that 22 offer mathematics and biology. So that means you have 22 minus 7 also. That gives us 15 that offer biology only, biology and mathematics only. Then to get people that offered mathematics and history only as well, which is this place, then what do we have? We are told that 16 offer mathematics and history. 16 offer mathematics and history, not mathematics and history only. Then to get only, that will be 16 minus 7 as well. That will give us 9. I hope you understand that. So you are filling this space, you are filling this space, you are filling this space, you are filling this space. So we need to get biology only, history only, mathematics only. Now look at the circle of biology. You have gotten 14, you have gotten 15 years, you have gotten 17 years. Tell me you are looking for biology only now. How do we get that? So that will be how many people offer biology? 52 minus people that are here, minus people that are here, and people that are here. That will give us people that offer biology only. Do you understand what I've done there? Yes. 52 offer biology. So you have 52 elements in the biology. So, but 14 offer biology and history. 7 offer the 3 subjects. 15 offer biology and mathematics. So look at the circle. Then remove from this 52, remove 14, then remove 7, remove 15. Whatever you have left will be biology only. So we have 52 minus open bracket 14 plus 7 plus 15 equals to 52 minus 36. Because if you add this 14 plus 7 plus 15 together, give us 36. Remove it, that will give us 16. So that means 16 offer biology only. Go for history only as well. Look at the circle of history. You already have this place, you already have this place, you already have this place. Then remove 14 plus 7 plus 9 from 60. That will give us people that study history only. So we have 60 minus open bracket 14 plus 7 plus 9. That will give us 60 minus 30. That will give us 30. That over biology. Then for mathematics only as well, which is this place, look at the circle of mathematics as well. You already know this place, you already know this place, you already know this place. Add it together, remove it from 96, that will give us 65. Now we now know you are now filling all the spaces in the Venn diagram. Since nobody is idle, there are no students that are not doing any of the 3 subjects, so no one is inside the box here. So now means the union of the 3 subjects will give us the people that are in the universal set. So when you unite B union H union M, will give us the universal set, which is E. So how do we get that? That will be addition of every spaces you have in the the three sets, this plus this place plus this place plus this plus this plus this plus this. So we have a 16 plus 14 plus 30 plus 15 plus 7 plus 9 plus 65. So, and if you add them together, that will give us 156. So that means we have 156 students that took part in the examination, and that's what they have to find. How many candidates were there for the examination? 156. That's the union of all the three subjects. Next question: how many candidates offer one subject only? One subject only. People here offer one subject only. People here offer one subject only. People here offer one subject only. That will be 16 plus 30 plus 65. So that will give us 111. Then how many candidates offer two subjects only? Two subjects only. People that are here, two subjects only. People that are here, two subjects only. People that are here, two subjects only. So we have 15 plus 14 plus 15 plus 9, and that will give us 38. I hope you understand that question. It's quite interesting. Then if you understand this one, then when we now want to use, if you don't know the number of students that are offered the three subjects, then you can easily represent it with a variable x. Then you should all you need to do is to do it the same way we did this one as well. So this is what we are going to be seeing shortly in the next video, in the next slide. Now let's see. Another question is what you are seeing right now. A school sport team contains 68 students. A school sport team contains 68 students. Now you can see that means in the university there are 68 students. So that means university is 68. Are we there? 33 do field events. That means there's a set field event. I say let field event be FE. So wherever you see FE represent field events. So there are 30 do field events. So that means you have 30 elements in field events, 40 do field, and 40 do track events. Sorry, there's a mixed up here. This is 40 do track event, not field event again. Another typographical error. 40 do track event. So this is track event. So we say let TE be track event be TE. So this is track event 40. So there are 40 elements in track event. Are we there? If 15 students do field event only, look at that word. 15 students do field event only. You can see that they have included this word only. 33 do field events. You already know that 33 do field event, but now they're saying that 15 students do field events only. Where would they be? This 15, where would they be? I mean, they will be here. 15 students do field events only. Don't forget that this place will represent field event only now. I hope you understand that now. And 10 track events. 10 track events. Are we there? So where are we? And 10 track events. There's a mixed up somewhere. And 10 track events. There's a mixed up here somewhere also. It's not track event, it's track event and another event there. It is track event and swimming. I don't know why this mixed up is coming. I don't know why it's so. It is 10 do track event and swimming. 10 do track event and swimming. So the reason why you're having 10 minus s here because they did not say that 10 do track event and swimming only. But let's go again. Then 23 do swimming. 23 do swimming. That means all the elements in swimming is 23. 14 do both field and track events. 14 do both 14 do both field and track event. Field and track event 14. So you're having 14 minus x here. I'm going to explain why you have it like that here. Then 8 do both swimming, both swimming. So that's where the mistake comes in. This is 10 do both swimming and do track event and both swimming. Then 8 do both swimming and track event. 8 do both swimming and track event. 8 do both swimming and track event. So the question is mixed up somehow, probably when they are typing it. So then the question is how many do swimming only? That means they want us to know swimming only here, track event only here as well. Then all the three subjects. So this is the question. So we don't know how many of them did all the three all the three events. So we can say that let x be represent field event intersection, track event intersection, swimming. So that means all the elements here, you can say it is what, x. So you can represent the people that did all the events to be x. So if you know people that did all the three events to be x, then you can find people that do field events and track events. Since you have been told that the 14 do both 14 do both field and track event. If 14 do both field and track events, they did not say that 14 do both of them only. If they said that 14 do both field event and track event only, then will be right, you write 14 here, but you don't put only. That means you need to remove people that are here from it, just like we did here. Sorry, just like we removed 7 from 21 here, that gave us 14. The same thing there, you remove your s from people that did both uh, track and field events. Also 10 do track event and swimming. 10 do track event and swimming, but did not say that track event and swimming only. If they say track event and swimming only, that means just write 10 here. So since they did not put only, that means you have a 10 minus people that are here, which is x. Also we are told that 8 do both swimming and track event. Both swimming and track events. So 8 do both swimming and field events, which is in this place. So since they did not put only as well, you write 8 minus x as well. So for this one, we have already gotten a field event only, but for track event, we need to get track event only. So you already giving this one in the question. 15 do student do field event only. You already have that, but you don't have this one. So how do we get track event only? We have 40 student, 40 element in the track event. Then how do we get track event only? That will be 40. Track event only will be 40 minus, look at the circle of track event, this plus this plus this. So we have 40 minus 14 plus x, 14 minus x plus 10 minus s, which is what you're having here. Then if you collect like times, 14 plus 10 will be 24, minus s plus l will give us 0, 0 minus l will give us minus l. That means you have into bracket 24 minus x. If you open the bracket with the minus, you have 20 minus 24, then minus times minus will give us plus, so we have plus s. So that will give us 40 minus 24 give us 16 plus x. So that you're having 16 plus x here. Also to get a swimming only now, what do? You have 23 that are in 23 elements in the swimming. Then look at the circle of swimming. That means you need to remove this plus d plus d from 23, and that's what we're having here as well, and that will give us 5 plus x. I hope you understand that now. Then we need to get the value of our x first before you can now do anything. Then how do we find the value of x? It's easy. You can do this plus this plus this plus this plus this plus this plus this equals to what? 68. Collect like times, you get the value of your x. That is the union of field event plus track event plus swimming should give us uh 68. Then for me, you can find your x. So then that's a long walk. But since we know we can use this one of these to find our value of our e x rather. So we know that all the elements in this field event should give us 33. So we can say this 15 plus this plus this plus this should be equals to what? 33. So 15 plus 14 plus minus s plus x plus 8 minus s. All the elements in this circle should give us what? 33. From there you can collect like time. 15 plus 14 is 29 plus 8, 37. Minus s plus s is 0 minus s. So we have minus s equals 33. Collect like times. Minus s is equals to 33 minus 37. That go minus 4. So s is 4. So that means 4 you have 4 elements that did all the sports. Then question now say that we should find swimming only. Swimming only is 5 plus x. So 5 plus 4 will give us 9. Then track event only. Track event only is 16 plus x. That will be 16 plus 4. That will give us 20. Then all the 3 events that we already gotten, which is x. That is 4. So for this question, you may consult New General Mathematics SS1. The one of the exercise question there is this question. So if you want to write the correct question, you have the New General Mathematics SS1 textbook. One of the exercises, the question there is one of these questions we are having there. So if you want to cross check that to correct this error that we have in the question. So that's the solution to that question. Let's see another question to help us understand the Venn diagram of 3 subsets better. Now, in a class of 55 students, that means the inverse set is having 55 elements in the inverse set, and that's what you have here. 21 study physics. So in physics as the element, we have 21 elements there. 24 study geography. Geography, you have 24 elements, and 23 study economics. So economics has 23 elements in it. Then C study both physics and geography. C study physics and geography, but it didn't say physics and geography only, so we keep that. Then A study both geography and physics and economics rather. Geography and economics 8, but did not say geography and economics only. 5 study both economics and physics. Physics and economics 5, but did not say physics and economics only as well, so we keep that. Then if X study all the 3 subjects, so that means we know the value of people that study all the 3 subjects, which is X. So you write X there, sorry, excuse me. X will be here. Then you can now go back to physics and geography only, 6. Then to now know geography, physics and geography only now, that will be 6 minus X. To know geography and economics only, that will be 8 minus X as well. Then to know economics and physics only as well, that will be 5 minus X. So now, and we are now told that 2x study none of the 3 subjects. That means there are some people that are idle that did not do all the 3 subjects, and they call it 2x. So that means you have 2x inside the box, outside the circles. Then that means we need to get physics only, geography only, and the economics only to complete the Venn diagram. Then how do we do that? So it's very simple. In the circle of physics, physics in the set physics, you already fill this place, you already fill this place, you already fill this place. So that will be 21 minus this plus this plus this. So get physics only, you have 21 minus open bracket 6 minus s plus 5 minus s. Simplify that, that will give us 10x, because you have 6 plus 5 give us 11. Then minus s plus f give us 0. Then minus that means you have 11 minus x inside the bracket here. Open the bracket with the minus, you'll be having 21 minus 11 plus x. So that will give us 10 plus x. So for geography only as well, look at the circle for geography, and you discover that we have 24 minus this plus this plus this, as you can see here. And if you simplify that, so that's as well, you have 10 plus x. Then for economics only as well, we have 23 minus, look at the circle of economics, this plus this plus this, remove it from 23, and that will also give us 10 plus x. Then from there, the question says we should find the value of our x. And how do we do that? The union of physics and geography and economics, then plus people that are high do should give us the number of elements in the universal set, which is 55. So this plus 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 this will give us 55. And that's what you have in here, that 10 plus x plus 6 minus s plus 10 plus x plus 5 minus x, where am I? Then plus 8 minus s plus 10 minus 10 plus s, then plus 2x is equals to 55. That you have added the union of this and this and this and plus this together to give 55. Then if you simplify that to get you have 10 plus 6 plus 10 plus 5 plus 8 plus 10, that will give us 49. S minus x give us 0, s plus x give us 2x minus x minus s, that will give us 0. Then s plus 2s will give us 3x, then equals to 55. Collect like time, we have 3x equals to 55 minus 49, then that will give us 6. Divide both sides by 3, that will give us 2. Our s is 2. So if our s is 2, then the number of students that study physics only. Physics only is 10 plus x. So that give us 10 plus, so that give us 12. Then the number of students that study only two subjects. Only two subjects. People that here study only two subjects. 6s minus s plus 5f minus s plus 8f minus x. So that means you have a 6 plus 5 plus 8, that give us 19. Then minus s minus s minus s give us minus 3x. Then s is 2, that will give us minus 6. Then 19 minus 6 will give us 13. So that's the solution to that question. That question is also a past WAEC question as well. I think we need to solve one more question before we call it a day on Venn diagram of both two subset and three subset. And before we solve that question, if you have not subscribed to this channel, please do that by clicking the subscribe button on this channel right now, so that you'll be notified whenever we post video on this channel. Now the last question is what you are having. No, is it the last question? Yes, the last question. What you are having right now in a roadworthiness test. In a roadworthiness test on 240 cars, 60% passed. In a roadworthiness test on 240 cars, 60% passed. This question is a WAEC pass question, 218, question number 6 in the WAEC pass question there. In a roadworthiness test on 240 cars, 60% pass. Full stop. The number that failed had fault in clutch, brakes, and steering as follows. That means they are not talking about people that passed, they are talking about people that failed. Not people now, cars that fail rather. So their focus on their failure, not their pass. So if 60% pass, 60% pass, then how many people, how many percent failed? That will be 40% will failed, because this is 60 over 100. So 60 out of 100 is 40. So that means then those cars that failed are 40 in number. Sorry, 40%. 40% failed. Then 40% of 240 cars will give us how many cars that failed. We have 240 cars in total. I hope you understand now. Then 60% pass. Then the number that failed are 40%. Those 40% of 240 will give us number of cars that failed. Do you understand that now? So I said if 60% pass, then 40% failed. There 40% of 240 cars is 96. That means you have 96 in the universal set, 96 cars. Now the question said that the number that failed had fault in clutch, brakes, and steering. That means we have a set for clutch, set brake, then set steering. So we have set clutch, set brake, set steering. Are we there? So the number that failed had fault in clutch, brake, and steering as follows. Clutch only. Look at the question now. Clutch only 28. You can pause the video and ask yourself, where are you going to put that value? Clutch only. They have put only now. Clutch only. So that means it's going to be here 28. Clutch only is here. Then clutch and steering 14. Here they not put only now. Clutch and steering. So after you might have drawn a circle for clutch, a circle for brake, another circle for steering, then you put your clutch on the 28, then clutch and steering they say 14, but we are not told that it's a clutch and steering only, so we leave it down for forever, leave that one. Then they say clutch, steering, and brake. So that means we have seen the intersection between the three faults. Clutch, steering, and brake, they are what? 8. So write that 8. So when you know the intersection between them 8, they can actually come and get your clutch and steering only. So if you know clutch and steering to be 14, that means clutch and steering only will be 14 minus this 8. That will give us 6. Do you understand that? Good, if you understand. Then clutch and brake. Clutch and brake now, which is intersection between clutch and brake. They didn't say clutch and brake only also. So that means you have 20 minus 8 as well. That will give us 12. Are we there? Then brakes and steering only now. Brake and steering only. They can say that they put only here also. Brake and steering only. That means this plate, that means 6. So you can see that we did not remove anything from this one. You have 6 there. Then steering only is twice brake. Steering only. Steering only is twice brake. I hope you understand that. That's it. This is another word problem included in that question. Steering only, this is steering only, is twice brake, 2 times brake. But we don't know steering only is twice brake only. So we don't know brake only. So if you know brake only, we know steering only. According to this statement here, steering only is twice brake. So since we don't know steering only, but we are told that steering only is twice brake only. So if our brake only is X, then we note our steering only. So we say let our brake only be X, then our steering only will be what? 2X, according to what you are having here. Then draw a Venn diagram to illustrate the information, which is what you have drawn, and nobody is idle in the diagram. Then how many cars had fault in brakes? So we cannot get that unless we first know the value of our X. And how do we get that? Is by finding the union of everything to be equal to 96. So, and that is you have 28 plus 12 plus x plus 8 plus 6 plus 6 plus 2x equals to what? 96. Collect like times there, you are having 28 plus 12 plus 6 plus 6 plus 6. That will give us 60. X plus 2x will give us 3x equals to 96. Collect like times, we have 3s is equals to 96 minus 60, then 3 equals to 36. Divide both sides by 3, that will give us 12. So that means brake, this place have 12 cars. Brake only has what? 12 cars. And that's what you have to find. How many cars had fault in brakes only, which is X. And that means you have 12 cars there. There's only one fault. How many cars had only one fault? This one have only one fault, which is clutch. Only one fault, only one fault as well. You understand that now? So we have 28 plus x plus 2x. 28 plus x plus 2x. So if you simplify that, we have 28 x plus 2x give us 3x. 28 plus 3x, and our s is 12. 3 times 12 will give us 36. So 36 plus 8 will give us 64 cars. So 64 cars has only one fault. 64 cars have only one fault. So that is the end of this uh, question and the end of all the questions we are going to solve on Venn diagram of three subsets. I hope you have been able to learn one or two things from the beginning of this tutorial to this present moment, and uh, I know that you have learned one or two things from here. So we are still going to be solving more questions on the Venn diagram as we come across them in the past question and other materials. So you may need to stay tuned, and I hope we'll see you in the next video. Please do subscribe, share the video with the student that want to write WAEC, NECO, and other examination. And I will see you in the next topic we are going to discuss. May the good Lord bless you. Thank you, and God bless you.